This is my full-size, full-function router table with a 2¼ horsepower router mounted to it. But it can fold away for storage or transport in just a minute with no tools. And we're going to build it here in Season 2 of Woodcademy. You know that I'm going to tell you to wear your safety glasses and use proper hearing protection when working in your shop. But other aspects of your appearance are also important to consider from a safety standpoint. Articles of clothing, dangling jewelry, or even long hair are all potential hazards in the shop and must be controlled. Long sleeves are best avoided, but if they can't be avoided, they either need to be tightly wrapped around the wrist, or better yet, rolled up to the forearms, and again, tightly controlled so they won't dangle. Necklaces or other dangling jewelry, including earrings, either need to be tucked in, or better yet, simply removed until after the workday is over. And long hair also needs to be tied back and kept under control while working in the shop. Remember, your best safety device is contained between your ears. You are your own best protection. Now, this particular table here is the original that I built right around 2012. I've been using it for 6 years, and it's functioned wonderfully. But over that time, I've figured out a few things that I'd like to do to upgrade it and make it even better. And we're going to build the upgraded version. Now, the most visible change for the upgraded version is going to be switching from using 2x6 lumber to make the frame to going to 2x8 lumber. And that's going to extend the distance from the pivot to the locking knob, both top and bottom, a little bit farther apart, which will add to the stability. The biggest change is one that's not going to be seen. The pivot bolt and the locking knob are going to be moved farther apart by changing from 2x6 to 2x8 framing here, but also they're going to run through a more tightly controlled path connecting these two pieces together, which will take out some of the play that's in the connecting system right now and should tighten this up quite a bit. It hasn't really been a problem in using this for the last 6 years, but I figured out a way to make that system better, so we're going to adopt it in the new version. The original design had a 5/16 inch diameter hole drilled all the way through both pieces, and I used a nylon sleeve to protect the wood to keep the bolt from tearing it up, and then had the T-bolt on the other side. But that does leave a gap around our bolt, and this sleeve isn't very heavy duty, and so that's where the play is coming from. With the updated version, we're going to have a 5/16 hole for the T-nut, but then the rest of the hole through both pieces is going to be bored to a 1/2 inch, and we're going to use 1/2 inch nylon spacers with a 1/4 inch center to fill that entire gap. It's a better fit, and there's less chance of wear in here, so you're going to get a tighter fit without having to crank down on these bolts too hard. The aluminum-bodied fence that I built for this router table is also going to get a few upgrades. It's been excellent, and I've been very happy with it, but there's a few changes I want to make. I used the 2-inch multi-track from Rockler for the top to hold the whole thing together, and attached 2 pieces of the 3-inch to create the front of the fence, or at least the body of the fence. And I want to use the 3-inch for both now, so that this extends across to the face of this piece, and that way I don't have this weird step in between, and it's going to make adding guards and other things a little bit more easy to do, and it'll give it a little more structure. The other change we're going to make to the fence is to add a second bracket to hold the face to the top of my fence body. This has worked pretty well, but there have been a couple of times where the fence has gotten hit and I've had to realign the two fence faces to make them parallel. Adding a second bracket will hold that very solidly in place, and I don't think it'll ever move once it's locked down. So we're going to add that second set of brackets here as well. One of the other changes we'll be making is tool organization. As I use this, I stored the Allen wrench needed for the fence up here at the top. I've got my adjustment handle for the router lift mounted to a block down here. I've got my wrenches and such. I kind of added these things in as I went. And in the new version, we're going to use this cross stretcher down here to build a little tool area where all of these things can be kept in one well-organized space. All of the parts for the folding stand can be cut from a pair of 8-foot 2x8s. I used my circular saw to cut the pieces a little long, then squared them up and cut them to final length on the table saw. The two cleats that hold the router table top can be cut from a single piece of 2x8. Strike a line down the middle of the stock, and the two parts can be laid out starting off this line. At this point, we're laying out the shape of the cleats, the hole location for the handle, and marking the center line where the upright will meet. The locations of the pivot holes will be marked out later using a jig to ensure accuracy. The feet can be laid out as well, but of course they require the full 7¼ inch width of the 2x8. Again, we're laying out for the shape, marking the hole for the axle, and marking the center line of where the foot will meet the upright. There will also be a stretcher running between the 2 feet, so the mortise locations need to be marked out. And don't forget that the 2 feet need to be laid out as mirror images of one another. Shaping the cleats begins by ripping the stock in half along the center line, then ripping both pieces to final width. The cleats and the feet can now be cut to shape on the bandsaw. Work carefully and follow the lines closely. It'll save you a lot of cleanup afterwards. Then all the parts are sanded smooth and to the lines using the appropriate sanding techniques for each section. Now, nothing about this frame assembly is terribly difficult, but we do need to make sure that the holes that we drill into the cleat and the leg for the pivot and the locking mechanism as we fold the piece up, those holes have to line up pretty much perfectly with the holes we put into the uprights. And that's why we created this drill jig. Now, we're not going to use the drill jig for actually drilling. We're going to do that on the drill press, but this is going to mark out the holes for me. And we've got a center line marked with a little notch in place so that when I put it in place, the mark that I have on my piece can be lined up pretty precisely and allow me to mark the holes. So on the measured drawings, there's a dimension for the center line of where we want the pivots on the cleat and on the leg. And we're just going to use that center line marked out to set the marking gauge in place and mark the holes. On the uprights, everything's designed so that this marking gauge goes dead center. So I'm just going to mark the center point of the top and bottom of this upright, of both uprights, put the marking gauge in place, and mark it out. So let me show you how I made the marking gauge. Start with a good quality 1/2 inch thick piece of ply, 2 inches wide and 7 inches long. Then mark this piece on the center line and 2 5/8 inches to each side. Each of the outside two lines then gets a cross mark exactly 1 inch down from the top. These are the locations of the guide holes. And then a small V-shaped notch is marked out on each end of the center line. A center punch is used to mark the hole locations, and they're drilled through using a 1/4 inch bit. The notches are then cut to the center line of the jig using the bandsaw. And a simple 1 inch cleat attached to the top completes the jig. Now, if you watch the show during season 1, you'll recognize these, my dowel centers. And these are excellent for use in this kind of a jig where I can line the jig up to my center line and then just press it down in so that the dowel centers give me the impressions I need. But there's another way to do this that's even more effective. This is a set of transfer punches. They're basically sized pieces of steel with a point milled into the end of each one at the center line. And it comes in a set just like a bunch of drill bits. So in this case, I'm going to use the 1/4 inch center punch or transfer punch. It's going to fit right through that hole, and the point is going to be centered on that hole as it transfers through. What these allow me to do that the dowel centers don't is I can actually locate my marking jig first. I can even clamp it in place if I want to, and then because I have access through the part, I can lower the transfer punch, give it a tap, lower the transfer punch, give it a tap. And I have my marks here. So when I have the option of going all the way through, the transfer punch is actually an easier way to work. So I mark the center line of my upright, strike a line, set my jig in place, again using the notches that give me the visual. Nice clear markings. The pivot holes in the cleats and the feet are 1/2 inch diameter, bored all the way through. The dimple created by the transfer punch will automatically align the drill bit to the proper location. I purposely set all of the holes to be centered 1 inch off of whichever edge they reference from. This allows me to set a fence on my drill press to guarantee all of the 1 inch offsets are the same. I even set the axle hole 1 inch in from the end of the foot, so that can be drilled at this point as well. Now, in drilling all of these frame parts for our pivot bolts and our lock knobs, we have to be a little bit careful. On the cleats under the tabletop and on the feet, it doesn't really matter. Drill from either side. You're going all the way through with a 1/2 inch hole to take the nylon sleeves that will hold the bolt firmly inside the hole. But on the uprights, the 1/2 inch hole is only going to go 1 inch deep, and then the rest will be drilled at 5/16 to accept the T-nut. And I almost screwed this up. I laid out my mortise locations here, and I laid out the locations for my holes on this face as well. Except this is where the T-nuts need to go, on the inside of the two legs. So in reality, in order to line everything up properly, I want to drill the 1/2 inch holes down from this side, opposite of my mortise, and then at the bottom of that 1 inch hole, my Forstner bit will already give me a center point to guide the 5/16 bit the rest of the way through. Both ends of both uprights get this 1/2 inch hole bored 1 inch deep. It's the same fence position as before, just not drilling all the way through. These same holes in the uprights are now completed using a 5/16 inch bit. There is a center point left by the Forstner bit at the bottom of the hole. Ensure that the 5/16 bit centers on this point before you drill. One more pair of holes is needed before we move the fence on the drill press. A 1-inch hole for the handle is bored 3/4 of an inch deep into the inside face of each cleat. With the 1-inch Forstner bit still in the drill press, the mortises in the feet and the uprights can be milled out. Drill along the center line of the mortise to 3/4 of an inch deep. Then square up the mortises using a sharp chisel. The tenons are simply cut into the ends of the stretchers using a dado stack. To keep things simple, all 4 shoulders are cut the same, 1/4 inch deep, 3/4 of an inch wide. The T-nuts can now be inserted into the uprights, but they need to be perfectly aligned with the nylon sleeve, and simply tapping them in with a hammer may not guarantee that. So start by setting the nylon sleeve into its hole. Then slide the Allen head cap screw all the way through and thread the T-nut onto the end. Now when you tap the T-nut into place, the bolt and sleeve will guide it accurately. The edges of the 2x stock come already rounded over, but they can be pretty rough, and we have been shaping some parts. So all the edges get milled with a 3/8 roundover bit, and all the parts get sanded in preparation for dry fit. It's always a good idea to verify your work with a dry fit, but it's especially important with this project. So I'm taking the time to clamp the stretchers between the uprights and the feet and checking to see how they fit together. We don't want to glue things at this point. We may need to adjust the length of the stretchers so the uprights fit properly between the feet. A 1-inch long spacer goes into each hole in the uprights, and 2 of the 3/4 inch long spacers are placed in the through holes in the feet. The pivot holes at the front are lined up and a 1/4-20 bolt threaded through into the T-nut. If the holes are accurate, the rear locking knob should thread right into place. And the same procedures are used to check the cleats at the top. Before beginning the assembly of the folding stand for our router table, let's talk about hardware for a minute. To assemble the router table, we need 4 of the press-on thumb screws. We need 8 1/4-20 by 3-inch Allen head cap screws, 8 washers, 16 of the 3/4 inch spacers. And that's because I'm using 2 3/4 inch spacers here. It's actually cheaper than buying 8 1-inch or 1.5-inch spacers here. Then we need 8 of the 1-inch spacers to fill in the upright pieces, and 8 T-nuts. And it's important with the T-nuts that the shaft here is not more than 1/2 inch so that everything works together mathematically. So you don't need a lot of hardware, but it's a little hard to find. If you're fortunate, you may have a well-stocked hardware store nearby where you can buy most or all of these components just in the quantities you need. I don't happen to have that luxury, so that's why I ordered everything from McMaster Carr, and that's the source that I give you in the plans. I provide you with sources where you can get all of the hardware that you need to span through the 2 pieces of 2x lumber that make up our frame for the pivot and the locking system. But The 3-inch bolts that we're going to require are a little bit hard to find locally, but a 3-inch long knob is not only going to be very difficult to find in any source, but it's also going to be relatively expensive. But there's a relatively cheap and easy way around it, and that's the plastic knob heads that I give you the source for in the plans. These are press-on plastic knob heads. They come in different styles. We're using the T-handle style here, but they fit over the cap, the end of an Allen head cap screw, and can be pressed together, and once pressed together, they're pretty much permanent. I love these things. I use them all the time because I can buy just the relatively inexpensive plastic caps and then pair them with bolts of whatever length I need for the task at hand. They're a jig maker's dream. So let me show you how those go together. There's 3 different ways to put them together, from the relatively simple to the more complex. Now you can just hammer them together, and that works very quickly and very easily, but it is a little risky because if the ground that you're pounding the head against isn't perfectly flat, you do risk breaking the plastic. I've done that once or twice, but in a pinch, it'll certainly work. But I prefer using a mechanical method. The vise is the easiest thing for most of us because most of us have a good vise. And then I'll show you an arbor press as well. If you're going to be doing a lot of these, investing in an inexpensive arbor press is not a bad idea. The plastic cap is set onto the head of the Allen screw. Then these are set between the jaws of the vise and pressed together. It's that simple. And once pressed together, it's very difficult to get them to come off again. Of course, an arbor press is fast and easy. It's specifically designed to press things together like this. The assembly begins by drilling a couple of pilot holes in the center line of each of the mortises. The mortise and tenon joints all get glued and then fitted together and secured with a pair of screws in each mortise run through the pilot holes. The cleats are attached to the top of the uprights with the pivot bolts and the locking knobs. This is the point where the handlebar gets glued and attached between the 2 cleats. This is all done the same as the dry fit, but with glue and screws in the mortise and tenon joints. Finally, the wheels can be added. A length of 1/2-inch threaded rod forms the axle that runs through the holes we already drilled in the back of the feet. Each end of the axle gets a washer, the wheel, another washer, and a nylon lock nut. At this point, we can begin laying up our router table top. And like all of our woodworking machines, the top wants to be absolutely flat in order to get predictable results from it. And the best way to ensure that the top starts flat and stays flat over time is to laminate it up out of layers of material rather than trying to work with one thick layer. Now, the original tabletop that I had was made up of 2 pieces of Baltic birch plywood bonded together with a piece of high-pressure laminate on top. And that worked out just fine. But I don't work in cabinet shops anymore, so getting my hands on a piece of high-pressure laminate that wasn't a 4x8 sheet was a little bit more difficult. So this time I chose to go a little bit different route. I had some Baltic birch hanging around. Any good quality plywood will work, but you want plywood on the bottom because a bunch of stuff is going to attach here and you need that security, that strength. In the center, I'm using 5/8 thick hardboard or press board, and I'm using it because it's relatively cheap. My home center has pieces 4x2 foot, so I'm not wasting a lot of material, but most importantly, it's very consistent in thickness across the entire face, and that just makes gluing up a flat piece much, much easier. And instead of high pressure laminate on the top, my home center sells an 1/8 inch hardboard with a melamine face, as a whiteboard. Again, a 2-foot by 4-foot piece could be bought relatively cheaply, and by bonding these three together, I get the top I need in the size I need without a lot of waste. So let's see how that's done. I cut the plywood layer to the exact size I wanted the tabletop, then cut the other two layers oversized so I could trim them back to the plywood after the glue up. I'll be using a vacuum press, so the 3 layers were bonded together using yellow glue. I've done it this way for decades, and it's never given me a problem. But not everybody has access to a vacuum press, and getting even pressure across a panel like this with clamps is difficult. If that's the case for you, I recommend using contact cement. It's inexpensive, doesn't require a special press or clamping calls, and I've used it successfully many times over the years. The advantage of a vacuum press is that it applies pressure evenly across the entire glue-up. In this speeded up clip, you can clearly see the pressure being applied as air is removed from the bag. And that's the sound of a good press. With the lamination completed, the top 2 layers can be flush trimmed to the plywood on the bottom. It's not strictly necessary, but I did add a 1/2 inch thick hardwood edge band all the way around the router table top. This does help protect the edges from damage. All of the sharp edges were then rounded off, and then I finished it off with some wipe-on poly. Our router table fold-away base and the top are now complete, and that completes episode 1. In episode 2, we'll add the router lift. We're going to plow a groove across the front of our table to add in a miter slot if you choose to use one, and we'll talk about that. I'm going to add a couple of holes in the folding mechanism so that we can use the lock knob to lock the thing folded, and I'll show you how to do that. And then we're going to build our aluminum bodied fence, add the dust collection port and a few accessories, and then we're going to build some storage down here along with adding our electric switch. That'll all be in episode 2. So stick around for that. Woodcademy is made possible with the generous support of our sponsors. Please take a minute and let them know how much you appreciate it.